October 21, 1936. High above the churning waters of the Golden Gate Strait, a lone figure, Alf B. Goedicke, a Norwegian sailor turned bridgeman, steps onto a catwalk just a few feet wide. Below him, nothing but 500 feet of empty, fog-filled air. The wind, a relentless, shrieking force, tears at his clothes, trying to peel him from his precarious perch. He, along with hundreds of other men, is engaged in a task of breathtaking audacity, weaving the very sinews of what will become the longest single-span suspension bridge in the world. But this is no ordinary construction job. It's a battle against gravity, against the elements, and against the very limits of what was thought possible in the 1930s. The partially completed towers of the Golden Gate Bridge rise like skeletal fingers into the sky, monuments to a dream that many believed was a fool's errand. The strait is a notoriously treacherous stretch of water, with currents that can snap a ship's anchor chain like a piece of thread. The winds that funnel through the gap between the headlands can reach hurricane force, and the bedrock of the seafloor is a mangled, chaotic mess. To conquer this place, to build a bridge that could withstand the furies of nature, would require a feat of engineering unlike any other in human history. The key to it all, the very heart of the bridge's strength, lay in its cables. But in 1933, when the project began, no one had ever successfully manufactured or installed cables of the immense size and strength required. This is the documented story of how the engineers and workers of the Roebling Company, armed with a century of innovation, wove wire ropes strong enough to hold the Golden Gate, and in doing so, created an icon that would stand for a century and beyond. In the early 20th century, America was a nation on the move. The automobile was no longer a luxury for the wealthy, it was the engine of a new, mobile society. But this new freedom of movement was often brought to a screeching halt by the limitations of geography. Ferries, once the lifeblood of coastal cities, were now a bottleneck, a frustratingly slow and inefficient way to cross the great waterways that defined America's landscape. Nowhere was this more apparent than in San Francisco. The city, a vibrant hub of commerce and culture, was hemmed in on three sides by water. To the east, the San Francisco Bay, and to the west, the vast expanse of the Pacific Ocean. To the north, the Golden Gate, a mile-wide strait that was both a breathtaking natural wonder and a formidable barrier to progress. For decades, the idea of a bridge across the Golden Gate was dismissed as a fantasy. The challenges were simply too immense. The span was too long, the tides too strong, the winds too fierce. But by the 1920s, the visionary engineer Joseph Strauss had convinced the city's leaders that it could be done. His design, a massive suspension bridge, was a marvel of engineering ambition, but it all hinged on one critical component: the main cables. These were to be the two great arteries of the bridge, from which the entire roadway would be suspended. They would need to be strong enough to support not only their own immense weight, but also the weight of the deck, the thousands of cars that would cross it every day, and the relentless forces of nature. The problem was, in the early 1930s, no company in the world had ever manufactured cables on this scale. The specifications were staggering. Each of the two main cables would need to be 36.5 inches in diameter, over 650 feet long, and contain more than 27,000 individual wires. The total weight of the two cables would be a staggering 24,500 tons. The American steel industry, for all its might, was not prepared for a challenge of this magnitude. The traditional method of manufacturing suspension bridge cables, which involved twisting wires together like a rope, was simply not feasible for a project of this size. A twisted cable of that diameter would be impossible to manufacture, transport, and install. It would also be weaker, as the outer wires would be under more tension than the inner wires. America didn't have a shortage of steel, but it had a critical shortage of the Wove technology to spin that steel into the unprecedented sinews of the Golden Gate Bridge. The entire project, the dream of connecting San Francisco to the north, was balanced on a knife's edge. Without a solution to the cable conundrum, the Golden Gate Bridge would remain nothing more than an audacious drawing on a piece of paper. The solution to the Golden Gate's cable crisis came not from a flash of sudden inspiration, but from a legacy of innovation forged over a century of hard work and relentless dedication. The story begins not in California, but in Trenton, New Jersey, the home of the John A. Roebling Sons Company, and its origins can be traced back to a single man's John A. Roebling himself. Born in Prussia in 1806, Roebling was a brilliant and ambitious engineer who immigrated to the United States in 1831 with a dream of building a utopian agricultural community. That dream soon soared, but Roebling's engineering genius found a new outlet. In the 1840s, while working on the Pennsylvania Canal system, Roebling observed the constant failure of the thick, hemp ropes used to haul canal boats over the Allegheny Mountains. The ropes were expensive, unreliable, and frequently snapped, sending boats and cargo crashing down the mountainside. Roebling, drawing on his engineering training in Germany, had an idea. He developed a method for twisting iron wires together to create a flexible, yet incredibly strong, wire rope. His invention was a revolution. Roebling's wire ropes were not only stronger and more durable than hemp, but also cheaper to produce. The Roebling Company was born, and it quickly became the premier manufacturer of wire rope in the United States. John A. Roebling's ambition, however, went far beyond making better ropes for canal boats. He saw the potential of his invention to transform the very landscape of America. He began designing and building suspension bridges, using his wire ropes to create spans of a length and grace never before seen. His crowning achievement was to be the Brooklyn Bridge, a monumental structure that would connect the then separate cities of New York and Brooklyn. Tragically, John A. Roebling would not live to see his masterpiece completed. A freak accident during the final survey for the bridge in 1869 crushed his foot, and he died of a tetanus infection just a few weeks later. But the Roebling legacy was far from over. His son, Washington Roebling, took over as chief engineer of the Brooklyn Bridge, and against all odds, completed the project in 1883. The Roebling Company continued to innovate, developing new and better methods for manufacturing wire rope and building suspension bridges. It was this relentless drive for innovation, this century-long accumulation of knowledge and experience, that would ultimately provide the solution to the Golden Gate's cable crisis. When the call came for a company that could spin the largest cables ever made, there was only one name that was truly up to the task: Roebling. When the Golden Gate Bridge project was put out to bid, the Roebling Company faced stiff competition from the behemoth of the American steel industry, U.S. Steel. But Roebling had an ace up its sleeve, a revolutionary technique for spinning suspension bridge cables known as parallel wire construction. This method, which John A. Roebling had pioneered on his earlier bridges, was the key to creating cables of the immense size and strength required for the Golden Gate. The traditional method of making bridge cables involved twisting pre-made strands of wire together, much like making a conventional rope. But for a cable as large as those required for the Golden Gate, this method had a fatal flaw. In a twisted cable, the outer wires are stretched more than the inner wires, meaning they carry a disproportionate amount of the load. This makes the cable weaker and more prone to failure. Roebling's parallel wire method, as the name suggests, involved spinning each of the 572 individual wires in the cable in parallel without any twisting. This ensured that every single wire carried an equal share of the load, making the cable far stronger and more efficient. The process was a marvel of engineering choreography. First, a lightweight, traveling wheel would carry a loop of wire from one of the massive concrete anchorages on shore up and over the two 746-foot towers to the other anchorage. The loop of wire would then be secured, and the wheel would return with another loop, repeating the process over and over again. Each wire was a single, continuous strand of galvanized steel, about the thickness of a pencil. The workers, known as spinners, would ride on catwalks suspended high above the water, their job to guide the wires and ensure they were laid perfectly parallel to each other. It was a slow, painstaking process. It took 6 months and 9 days to spin the 2 main cables of the Golden Gate Bridge. The work was also incredibly dangerous. The spinners worked without safety nets for much of the project, and the high winds and a constant risk of falling equipment made every day a life or death gamble. There were several technical challenges that had to be overcome. One of the biggest was ensuring that each of the thousands of wires was at the exact same tension. A single loose wire could create a weak point in the cable, with potentially catastrophic consequences. To solve this, the Roebling engineers developed a system of hydraulic jacks that could make minute adjustments to the tension of each wire. Another major challenge was compacting the thousands of loose wires into a solid, uniform cable. Once all 27,572 wires were in place, they formed a loose, hexagonal bundle. To compact them, the workers used a series of powerful hydraulic squeezers that moved along the length of the cable, compressing the wires together with a force of 400-500 pounds per square inch. Finally, the compacted cable was wrapped in a protective sheathing of wire to protect it from the elements. The result was a cable of a size, strength, and elegance that had never before been achieved. The Roebling Company's mastery of parallel wire construction had not only solved the Golden Gate's cable crisis, it had set a new standard for suspension bridge design that would last for a century. Winning the contract for the Golden Gate Bridge's cables was one thing. Actually producing and installing them was another. The scale of the project was unlike anything the Roebling Company, or any other company for that matter, had ever undertaken. The first challenge was simply producing the sheer volume of wire required. The Golden Gate Bridge would need 80,000 miles of wire, enough to circle the globe 3 times. This was a massive undertaking, even for a company as large as Roebling. To meet the demand, the company had to run its mills in Trenton, New Jersey, 24 hours a day, 7 days a week. The company went on a hiring spree, bringing in a new generation of workers to man the furnaces and drawing machines. Many of these new hires were young men from the surrounding area, desperate for work in the depths of the Great Depression. The work was hard and dangerous. The mills were hot, noisy, and filled with the acrid smell of hot metal. Workers had to be constantly vigilant to avoid being burned by molten steel or caught in the powerful machinery. But for many, it was the best job they could find, and they took pride in the fact that they were contributing to a project of national importance. Once the wire was produced, it had to be transported 3,000 miles across the country to San Francisco. The wire was wound onto massive spools, each weighing several tons. These spools were loaded onto specially designed railroad cars and sent on a week-long journey to the West Coast. At the bridge site, a new set of challenges awaited. The Roebling Company had to build a temporary city to house and support the hundreds of workers who would be involved in the cable spinning operation. This included dormitories, a mess hall, and a hospital. But the biggest challenge of all was the work itself. The cable spinning operation was a race against time. The project was on a tight schedule, and any delays would be costly. The work was also incredibly dangerous. The spinners had to work on narrow catwalks, hundreds of feet above the treacherous waters of the Golden Gate. The high winds were a constant threat, as was the risk of falling tools or equipment. The company took safety seriously and implemented a number of innovative safety measures. The most famous of these was a massive safety net that was suspended beneath the bridge. The net, which cost $130,000, was a revolutionary idea at the time, and it saved the lives of 19 men who fell from the bridge during construction. These men became known as the Halfway to Hell Club. Despite these measures, the work remained perilous. In February 1937, a scaffold collapsed and fell through the safety net, killing 10 men. It was a tragic reminder of the human cost of this monumental undertaking. The true test of the Golden Gate Bridge's cables and the Roebling Company's innovative manufacturing process would come not in a single, dramatic moment, but over decades of relentless service. The bridge, which opened to traffic on May 27, 1937, was an immediate and resounding success, but its long, short-term survival was far from guaranteed. The Golden Gate is a place of extreme weather, and the bridge would be subjected to a constant barrage of high winds, corrosive salt spray, and the ever-present threat of a major earthquake. The first major test came in 1951, when a powerful winter storm packing winds of up to 69 miles per hour battered the bridge. The bridge's roadway was seen to be undulating in a wave-like motion, a terrifying spectacle that was reminiscent of the infamous collapse of the Tacoma Narrows Bridge in 1940. But the Golden Gate held firm. The Roebling cables, with their immense strength and flexibility, absorbed the energy of the wind and prevented the bridge from tearing itself apart. The incident did, however, prompt a major retrofitting of the bridge to improve its aerodynamic stability. The ultimate test, however, would be an earthquake. The Golden Gate Bridge is located just a few miles from the San Andreas Fault, one of the most active earthquake zones in the world. In 1989, the 6.9 magnitude Loma Prieta earthquake rocked the San Francisco Bay Area, causing widespread damage and collapsing a section of the nearby Bay Bridge. The Golden Gate, however, emerged from the quake with only minor damage. The Roebling cables had once again proven their worth, their parallel wire construction providing the strength and resilience to withstand the immense forces of the earthquake. The combat validation of the Golden Gate Bridge's cables was not a single heroic event, but a long and grueling campaign against the forces of nature. The fact that the bridge is still standing today, more than 85 years after it was built, is a testament to the genius of its designers and the quality of its construction. It is also a testament to the legacy of John A. Roebling, a man who dared to dream of a new way of building bridges and whose company had the skill and dedication to turn that dream into a reality. The enemy the Golden Gate Bridge fought was not a foreign army, but the very earth and sky of its magnificent setting. And in that battle, the Roebling cables were the silent, unyielding soldiers that ensured victory. By the time the last wire was spun and the last rivet driven, the Golden Gate Bridge was more than just a bridge. It was a symbol of American ingenuity and determination. The numbers alone tell a story of incredible achievement. The bridge's two main cables, containing a total of 80,000 miles of wire, were a marvel of engineering. The total cost of the bridge, $35 million in 1937, was the equivalent of over $700 million today. But the true impact of the bridge cannot be measured in dollars and cents. The Golden Gate Bridge transformed the San Francisco Bay Area. It opened up the northern counties to development, and it turned San Francisco into a major transportation hub. It also became an instant icon, a symbol of the city and of the American West. But the legacy of the Golden Gate Bridge, and of the Roebling Company's contribution to it, extends far beyond the shores of San Francisco Bay. The successful use of parallel wire construction on the Golden Gate Bridge set a new standard for suspension bridge design. The technique was adopted for virtually every major suspension bridge built in the 20th century, from the Verrazano Narrows Bridge in New York City to the Akashi Keiki Bridge in Japan, the longest suspension bridge in the world. The innovations developed by the Roebling Company for the Golden Gate Bridge, from the traveling wheel to the hydraulic jacks used to tension the wires, became standard practice in the industry. Today, the spirit of John A. Roebling lives on in the countless bridges, elevators, and other structures that rely on the strength and durability of wire rope. The company he founded may no longer exist in its original form, but its legacy is all around us. The technology has evolved, of course. Modern suspension bridge cables are made from even stronger steel alloys, and the spinning process is now largely automated. But the fundamental principles of parallel wire construction, pioneered by a visionary German immigrant in the 19th century and perfected on a grand scale by his company in the 20th, remain the same. The Golden Gate Bridge is not just a monument to the past, it is a living, breathing testament to the enduring power of innovation. Let us return, for a moment, to that windswept catwalk high above the Golden Gate, to the men like Alf B. Dicker, who risked their lives to weave the sinews of a dream. Their story is one of courage, of skill, and of a quiet determination to do what had never been done before. The irony of the Golden Gate Bridge is that its most critical component, the technology that made it all possible, is largely invisible to the millions of people who cross it every year. The massive towers and the graceful arc of the roadway are what capture the eye. But it is the cables, the two great arteries of the bridge, that are its true heart. The story of the Roebling Company and the Golden Gate Bridge is a powerful reminder of America's industrial capacity, of its ability to mobilize its resources and its people to achieve great things. It is a story of how a legacy of innovation, passed down from one generation to the next, can provide the solution to a challenge that seems insurmountable. It is a lesson in the power of an idea and of the courage and determination it takes to turn that idea into a reality. Every time you see a suspension bridge, its graceful cables silhouetted against the sky, you are looking at a descendant of the technology that was perfected on the Golden Gate. The men who spun those cables, high above the churning waters of the Pacific, were not just building a bridge, they were building a legacy. They were proving that with courage, with ingenuity, and with a relentless pursuit of excellence, anything is possible. Every time you cross a bridge, held aloft by the strength of steel, you're experiencing the enduring legacy of a company that dared to weave the impossible, and in doing so, changed the world forever.